Uh, One end of a light inextensible string is attached to a mass of 4 kilograms which rests on a rough horizontal table. The coefficient of friction between the mass and the table is 1/4. The string passes over a smooth fixed pulley at the edge. It then passes over a smooth movable pulley, this guy here, of 20 kilograms, and over a smooth fixed pulley again. A mass of 5 kilograms is attached on the other end. Shown on separate diagrams the force acting on each mass. Now, what I want to bring your attention to here is that we're I think we're talking about the 20 kilogram pulley falling here. It seems to be significantly bigger than 5. Okay, so thinking about the 20, my guess would be 20 falls, 5 goes up. In fact, both of them fall, as in the 4 goes to the right. The 4 can only go one way. Okay, 20 is so large, we got to assume that the 5's going up and the 20 is going downwards. Okay, now the thing is about this one is that both masses can be affected in different ways. It technically can pull more string from one side than the other side. That's why you're going to have different masses. So I'll tell you how to really visualize this. Imagine that this one is so heavy it doesn't move. What would happen then? Imagine that the number 4 was so heavy it just isn't going to move. We'll call it 400 kilograms. Ain't going anywhere. What happens then? 20 falls, 5 goes upwards. I'm just after proving that there's not a common acceleration here. It just makes sense, doesn't it? That if that's that large, it ain't going to move, which means that the 4 kilogram mass and the 5 kilogram mass have two different accelerations. You happy with that? Okay. Now, that's in isolation, however. In isolation, where that is worth 400, okay, what's going to happen is that this one would rise up with 2a, and this one would fall down with a. That's in isolation, okay? Now that's not the case here. So remember that this one is roughly half of that one, because that's the only other acceleration with it. Now, what's going to happen at the moment is that we're going to have a system here where this is going to go with acceleration A. This one's going to rise with acceleration B. Now, what happens here is that this acceleration here is the average of the other two accelerations. Okay? So you add both accelerations together and divide by 2. That's what always happens when you have a system where two particles are linked to a movable pulley. The two particles have different accelerations. The movable pulley's acceleration is given to you by the average. Okay, just store that in memory. Use it anytime you see this system. Okay, it's going to be A plus B all over 2. Okay, your next job is to find out what is the you're going to have to draw each system in isolation. Okay, so we'll start off with the 4 kilogram mass. And in your leaving cert, you get a lot of marks for drawing these diagrams in isolation, so please make sure you do it. So what we're going to have is tension is the same because it's one string. So we're going to have tension yanking the 4 kilogram mass to the right. What opposes this, guys? Friction. So we're going to say friction equals mu r. R going up is the opposite of, anybody? What goes down? 4g. So it's going to be a quarter of 4g, which is g. G going to the left, so friction equals g. G going to the left and R going upwards. Okay, that's the 4 kilogram mass drawn. Then we're going to go pulley, 20 kilogram pulley. And for the 20 kilogram pulley, what are we looking at here? We're looking at the pulley has T going up, T going down. You're looking at 20g going downwards, and then you're looking at its acceleration being A plus B over 2 going downwards. Okay, once you're done with that, you're next going to do the 5 kilogram mass, and the 5 kilogram mass is going down at 5g, and it's getting supported by T. So you have all your systems are in isolation there, okay? Now, next thing we're going to do is we're going to set up the equations for each one. So let's put that there, and then I'll bring this one up here as well. Okay, just bring that down there because I want to do the equations for all of them. There we go. Okay, so that's all you need to look at. You just need to look at them in isolation to figure out what each equation is. So we're going to start off with the we'll start with the 4 kilogram mass actually. So guys, force MA equals your force, and then what is MA for this one? Anybody? 4 kilograms worth? Oh, one thing I forgot to put in was the acceleration of the 5 kilogram mass being B. Okay, so MA guys, what's the mass of the it's 4A, okay? We said that the acceleration is A, and hence 4A. Now, that's going to the right, so what force goes to the right? T. What force goes to the left? Friction. G minus G. That's one equation made up. Now you're on your second equation for the 20 kilogram pulley. So 20 kg pulley. How do you go about doing this? Is it going up or down for a start? So it's MA equals F. It's going to be 20 times. What's your question? How did you get the acceleration? What we're doing next, guys, is we're on the pulley. Okay, so the pulley is MA. So it's going to be 20 times A plus B over 2. That's going downwards. So what's going to lead here? Your 20G minus your 2T. Then that's going to be 10A plus 10B equals 20G minus 2T. Going to divide everything by 2. 5A plus 5B equals 10G minus T. Everybody alright with that? So, that's that there. Okay, so that's the second one done. Over here. Now we're on the third one, which is, third one's the 5 kilogram mass. Okay, so it's going to do that in purple here. So 5 kg mass. So what do we think of the 5 kg mass, guys? Up or down? Up. So MA equals F. M is 5. Your acceleration is B. Tension is winning. And then tension minus, that's going to be tension minus 5G. Now we have 3 individual equations there. So we have equation, this equation here. We have this equation here. And finally we have this equation here. And what does it want us to do? Calculate the acceleration of the 20 kilogram pulley in terms of terms. Okay, so it wants us to figure out what A plus B over 2 is. So it means we've got to isolate A followed by isolation of B. So let's see if we can isolate A for a second. I'd say what we're going to have to do here is something like this. I think we're going to have to get rid of all the tensions for a start. Okay, so I'm going to say, using the first one, I'm going to say tension equals 4A plus G. And then I'm going to insert that into the second equation. Okay, so it's going to be 5A plus 5B equals 10G minus, now minus T will be minus 4A minus G. Going to bring the 4A over the other side. I'm going to get 9A plus 5B. 9A plus 5B equals, what are we going to have here? Sorry? 9G. That's a simultaneous equation with with A and B. It was formed by using these two equations together, wasn't it? So we could form another one by mixing A and C together. Okay. So once again, I'm gonna do my T. I'm gonna plug in what T is. So I'm gonna get 5B equals 4A plus G minus 5G. Bring the 4A over the other side, I'm going to get minus 4A plus 5B. And that's going to equal, what's it, minus 4G. A really convenient way to get rid of that would be to multiply everything by minus 1, wouldn't it? So you're going to multiply everything by minus 1. Just use a different colour pen. Plus, minus, plus. I'm now going to get 13A equals 13G. Acceleration A equals G. Then I'm going to figure out what B is. So we have, I'm just going to say 5B equals, it's not moving, is it? Alright, so B, guys, alright, so B is 5B equals 9G minus 9A. 5B equals 9G minus 9G. B equals 0. Okay, so what does B equals 0 means? It means that the tension in the string equals its weight going downwards. Okay, so tension in the string equals the weight going downwards. This means that the only thing moving is going to be particle of 4A going right and the 20G particle going down. That is possible. Now, just trust your maths in this scenario, okay? So A plus B over 2 is your acceleration. Everybody agreed with that? And then we replace A with G, B with 0 all over 2. The answer is G over 2. Okay, so two particles of 6 kilograms and 8 kilograms rest on two horizontal tables. Coefficients on both tables and both particles is a half. They're connected by a smooth, inextensible string. What does that mean if you're connected by the one string? Tension's the same. Okay, we're going to assume, like last time, that both particles have individual accelerations, which they have to have, because if you made one of them really heavy, that wouldn't move, but yet the other one would probably fall. The only way, so we're going to call the one on the right has acceleration A, the one on the left has acceleration B. This acceleration has A plus B over 2, falling downwards of mass mg. Show that none of the particles will move if m is smaller than 6, and if m equals 12, find acceleration. We're just going to figure out the full system in terms of capital M, and then we can figure out what's actually going on. We're going to have to isolate A and B, like usual, okay? So, they both have friction, okay? We'll just do the friction really quickly. For the 6 kilogram particle, R goes up, 6G goes down, which means it's mu R, which is a half of 6G, so that's going to be 3G to the left. Everybody happy with that? And what would that make the other one? The other one has 8G weight going downwards, and that will mean 4G to the right for the friction. Always opposing motion, okay? Now once you have this done, guys, okay, what we're going to do next is set up our system, okay? We'll start off with the 6 kilogram weight. So what does the 6 kilogram weight do? What's MA, guys? MA? MA? 6A. Force going to the right? T minus 3G. Very handy. What about the other one? The 8 kilogram particle? Sorry? 8B equals T minus 4G. Another one. Very convenient, okay? And then finally the last one, the mg particle, m pulley. So mass by acceleration, ma equals f. Capital M into a plus b over 2 will equal 2t, or sorry, mg minus 2t. Multiply the full system by 2. ma plus mb, multiply the other side by 2. 2mg minus 4t. Isolate A, isolate B. Okay. How to go about doing this? Okay, so we've got all of our equations downwards. Equation 1, 2, and up there. 3. Okay, so that's our. We need to isolate A and B. Okay, so how to go about doing this, guys? Let's get rid of the t's, systematically get rid of some t's. Okay, so I'm going to join these two together. Okay, and what we're going to get is, the algebra is harder than anything, to be honest. Isolate t. T equals 6a plus 3g. Everybody happy with that? And then in the other one, t is going to be equal to 8b plus 4g. We're going to combine each one individually with the this one here. So we're going to have two unique equations, okay? So what we're going to do is ma plus mb, no worries there, 2 capital Mg minus 4 times t. I'm going to use the green t starting off. So minus 24a minus 12g. Going to bring the 24a over the other side and factorise. So it's going to be capital M plus 24 times a plus capital M times b equals 2mg minus 12g. That's a combination of these two here. Are we happy with that? Going to try another combination now. Once again, capital MA plus capital MB equals 2mg. This times minus 4 times this one is giving me minus 32b. That right here. You can go if you want. Minus 16g. Everybody happy with that? Now that that's done, what we're going to do next is bring the 32b out the other side. So we're going to get MA plus M plus 32 times B. Do you remember I bring the 32b over the other side, followed by factorising it, okay? Equals 2mg minus 16g. Okay, now that you're here, you have two simultaneous equations, even though they might not really resemble it. There's your two simultaneous equations there, okay? So you have to pick one of them. Which one would we like to get rid of? I'd say we're going to multiply the bottom one, the top one by, we'll first multiply it by m over 24. Once we're done by multiplying by m plus 24, we're then going to multiply it by minus. So it's actually going to turn out, oh sorry, not m plus 24, my bad. Oh yeah, I have an idea. We're just going to, I'm going to multiply them both out. ma equals mb plus 32b. 2mg minus 16g. Then ma plus 24a plus mb equals, what is this one? 2mg minus 12. Okay.